So today what we want to look at are derivatives of inverse functions. Now, as we start with this warm-up here, okay, this warm-up is actually designed to kind of introduce a formula that we're going to be doing here. But I want you guys to see this, because obviously here we have f and its inverse. So if I wanted the derivative of the inverse of f, I would just find g prime. Okay? However, we may not always know what the inverse is. And we may not feel like finding it. And the fact of the matter is, we don't have to. Okay, that's what we're going to be recognizing today. Or we may not actually know what the function f is, but we know it has an inverse and we know one of its values, and or maybe one of the values of what its derivative at a single point. Okay, because maybe it's like a rate of change that we were able to measure or something like that. Well, if we wanted the inverse, then we can use this formula here to help us figure this out, okay? So let's, first of all, we see we have some g primes and f primes, so let's go ahead and actually find what g prime and f prime are. So here's f prime of x. What is that going to be?
1/2 to x minus 4 to the negative 1/2. And then times 1 if you want.
Times 1, yeah, with chain rule. So this is going to be 1 over 2 radical x minus 4. Okay. And then, of course, g prime. That one's nice and easy. 2x. Okay. So, what's g prime of 1? 2. Okay. What's g of 1?
5.
5. Now, f prime of g of 1.
So plug in 5 for the derivative.
Plug in 5 into the derivative. Good. So it's going to be 1 over 2 radical 5 minus 4. 1/2. Okay. What is 1 over f prime of g of 1?
1 over 1/2. So 2.
1 over 1/2, which is 2. Okay. What do we say g prime of 1 is? 2. And that right there brings us to the formula for today. Okay. We're going to look at this a little bit more. I want to see a couple of other things here. But this is the key part that we want to notice here, that the derivative of the inverse, f inverse prime of x, is going to equal 1 over f prime of f inverse of x. Okay? Or if you will, since we know that f and g are inverses of each other, we can simply say that g prime of x is 1 over f prime of g of x.
Is it g of 1 like it is there, or just g of x?
It's g of anything that's in the domain. In this case, x had to be greater than or equal to 0. Actually,
No, it had to be greater than 4.
no, x should be greater than or equal to 4, right? So anything,
Would that doesn't work then?
oh wait, no, hang on a sec.
What if it's
Hang on a sec here. Sorry, that domain isn't for f, that domain is for g. That domain is for g. Because notice if x is 0, the range for g is 4 or greater.
Yeah.
Okay? So the domain here is x is greater than or equal to 4. This domain is for g. Okay? This only works if f and g are inverses. Now notice here, if we were to graph these, notice here you can see the symmetry across that line y equals x. Okay, we draw the line here. Okay, here's our line y equals x. You can see that symmetry across the line with the inverses, but also notice that the derivatives are mirror images of each other as well. Okay? As a result, you remember back when you were doing perpendicular lines and the slopes were opposite reciprocals and you would always forget to do the opposite part? Okay? Well, what you were finding when you forgot to do the opposite part and just did the reciprocal is you actually were finding kind of the derivative of the inverse. Okay? So if it's a half, the derivative of the inverse is 2. Okay? Oop. Let's put that back. There we go. Now, here's that formula that I was just saying. Now there is one thing that you have to be careful about with this, and that is f prime of g of x cannot equal 0. So you could do this at any value of x as long as f prime of g of x does not equal 0. Now think about that. Why would that be, other than the fact that it's going to make our fraction undefined? Think about the whole reflection idea. If f prime of a value is 0, what do we have? A max or min or plateau, which means our tangent line is horizontal. If I reflect that across the line y equals x, what happens to that line? It's vertical. What's the slope of a vertical line? Undefined. Okay? So, you can still get the idea if you see vertical to horizontal and vice versa, but the formula requires us to have a defined denominator. Okay? Now, there is a proof here that we could follow. I'm not going to work through all of that. But notice we start here with the equation x equals f of g of x. That's because f and g are inverses, right? We could work through it, it's fine. Might as well. If I take the derivative of both sides, notice here, I'm using the chain rule on the right-hand side. Right, the chain rule here. So f prime of g of x times g prime of x. The derivative of x is 1, and then if I just solve for the derivative of g of x, I have to divide both sides by the f prime of g of x. And we're allowed to do that because we're limiting it to the cases where that doesn't equal 0. So that's where this formula comes from. It's actually a really easy derivation. Starting with the definition of inverse functions, x equals f of g of x, and just taking the derivative and simplifying. Okay? Now, there are a couple of other just quick details just to keep in mind as you're doing different problems related to these. If the domain is I for the function f, and f has an inverse, then notice if f is continuous on its domain, then the inverse is continuous on its domain. Okay? Notice there are two different domains here, potentially. If f is increasing on its domain, then the inverse is increasing on its domain. If f is decreasing on its domain, then f inverse is decreasing on its domain. So you'll see here, that makes sense if you think about the formula that we just had. If the derivative of the inverse is simply the reciprocal of f prime of g of x, it makes sense if f prime is positive, g prime is positive. If f prime is negative, g prime is negative. Okay? So these make sense. If f prime can't be 0, then this is going to be continuous. Okay? And then finally, if f is differentiable on an interval containing c and f prime of c does not equal 0, then the inverse is also differentiable at that point.
When you say f prime being positive makes g prime of x being positive, that's assuming that g of x is positive now.
No, actually, if no matter what the value of g of x is, if the derivative is positive,
Oh, with the g of x.
yeah, then the derivative of g is going to also be positive. Okay? And same thing here, if f prime of c isn't 0, you can take the reciprocal of anything. So as long as the g of x does not equal 0, then we can take f prime of that, or sorry, f prime of g of x does not equal 0, then we can take the reciprocal. Okay? So, here we have the official formula given for us. This is something that you need to just have memorized here. But let's go ahead and use this a little bit. Notice here f of x is 1/4 x cubed plus x minus 1. Now, if you tried to swap the x's and y's here and solve it to get the inverse, you're going to have kind of a mess on your hands. Okay, if you can even actually solve that. Sometimes a function will have an inverse, but it's either really, really hard or you can't really solve it explicitly. Kind of like when we were taking derivatives, we used implicit differentiation to take derivatives of things that couldn't be solved explicitly for y. Same kind of idea here. Okay? So, what's the value of f inverse of x when x is 3? Alright, so first of all, I need to find out what g of 3 is, or f inverse of 3 is. And this is where you've got to really think about the what is the value of the inverse when x is 3. So f inverse think about it this way. F inverse of 3 is going to equal some value of f, right? I'll just put y. Okay? Now, on the function f, okay, let me not use y because that's going to confuse things. I'll just use c. Okay? So, on our inverse, that's the point 3c, right? On f, that's the point what? C3. So how am I going to figure out what c is?
Plugging in 3 from
Plug
3 in
for the f of x. Yeah, so guess what? I know that 3 is going to equal that function. And there's nothing magical about c's. If you want to leave them as x's, you can. But I just wanted to try to avoid the confusion as we switch from one to the other. If I solve this original function for when it equals 3, I will get the value that f inverse of 3 equals. Okay? Now, this has some algebra we got to work out. I'm going to get rid of the 1/4 first of all, and also get it equal to 0. So if I subtract 3, I have a minus 4. If I multiply everything by 4, that's going to give me 0 equals c cubed plus 4c minus 16. And then we got to figure out how to solve that somehow. Okay. It's a cubic. Alright, so how do you propose we solve that equation?
Factor by grouping?
No, because there's only 3.
Oh,
Long
that's
division
a-
or synthetic division? The rational root theorem?
Is that
The P's and
trinomial
Q's?
thingy? Like, is that a perfect trinomial?
It's not for a couple things. First of all, the c is cubed, not squared.
Oh right.
So that's what makes this a little more challenging. If it was squared, then we could use the quadratic formula. That would be nice. But, okay, so we got to figure out what this equals. Let's try some stuff. Remember, the possibilities are going to be plus or minus any of the factors of 16. So I'm going to list the coefficients. I have a 1c cubed, 0c squareds, 4c's, and a minus 16. I could try 1 and -1. Those aren't going to work though.
4.
Let's try, you want to try a 4? We could do 2 or -2, 4 or -4. Let's try some here. Carry it down times 4, carry it down times 4, carry it down times 4. That's not going to work. Okay? Because remember, it should end up being 0, right?
-2 or
So, you want to try -4?
It doesn't work.
You just try -4? Okay.
+2.
Yeah, it has to be.
Positive 2?
Yeah.
Okay. So bring down the 1 times 2, add down times 2, add down times 2. Oh, there we go. Good. And don't forget how this works then, is that means this whole thing factors into an x minus the positive 2, and then, well, actually we're dealing with c's, okay? And then this is going to be a c squared plus 2c plus 8. And you can try, but that's not going to factor. And if you do the quadratic formula, you're going to get imaginary roots. Okay? Just to cut corners a little bit on time. Oh, do you need it? There. So the only real answer is going to be c equals 2. Okay? Not real numbers. Okay? So that means that the inverse, okay, therefore, f inverse of 3 equals 2. So notice, if I want f inverse of a value, I set the original function equal to that value and solve it. Because I got to get the point. Okay? Now, what's the value of f inverse prime of 3? Well, using our formula, f inverse prime of 3 is going to be 1 over f prime of f inverse of 3. We just figured out that f inverse of 3 was 2. So it's 1 over f prime of 2. And f prime of 2 we can get pretty easily here. F prime is 3/4 x squared plus 1. So f prime of 2 is 3/4 times 2 squared plus 1. Well, that's 3 plus 1, which is 4. So I know this is 1/4. Yeah.
I thought that formula is for g prime of x.
Well, remember, g in the formula is the inverse of f.
Oh, and you, okay.
Okay, and I don't care which notation you use, if you like using the f inverses or if you like using the g's, it makes no difference. Okay, you could use smiley face and frowny face for inverses if you want. Probably get a little tedious, but it works. Remember, variables are just placeholders for values, so you can use anything you want, really, as long as you're consistent. All right. Does that make sense? Notice at no point did we know what the actual function f inverse of x equals. In fact, if you tried to find it, you'd get stuck. Okay? Yes?
Where'd you get that C minus 2 from like the beginning of it?
Remember we were trying different factors of 16.
Okay.
So since positive 2 worked, c minus the positive 2 is a factor.
Yeah.
And we know it works because this came out to have a remainder of 0. Okay. All right. Let's try another one, okay? So it says, let f of x equal x squared for x greater than or equal to 0, and let f inverse equal the square root of x. Now, we know just by the parent function that the domain of f inverse here is what?
Greater than or equal to 0.
Yeah, x has to be greater than or equal to 0. So guess what? Both of these have the same domain and range then. Yeah, x would be greater than or equal to 0 for the range as well. Okay? So show that the slopes of the graphs of f and f inverse are reciprocals at each of the following points. Okay? So we need f prime, which is 2x. We also need f inverse prime, which is 1 over 2 root x, right? So, at this point here, f prime of 2 is 4, and not g, f inverse prime of 2 right, not of 2, of 4. Yeah, we're at the other point. Is 1 over 2 root 4, which is 1/4. Okay? Over here, f prime of 3 is 6. From this one, f inverse prime of 9 is 1 over 2 root 9, 1/6. Okay, so they are reciprocals of each other. You can see it down here. We have the 6 and the 1/6. And we have the 4 and the 1/4. Okay? And that's all there is to it. Every problem, though, this is just a confirmation of our formula here. But notice every problem that you're going to use this formula for is really going to behave the same as this one. Okay?